Okay, so in the last video, we talked about the difference between series circuits and parallel circuits. Just to quickly recap, in, in a series circuit, you basically only have one pathway for the current to take. And so all of the components, all of the resistors, all of the lambs, whatever, in the circuit, the current is the same through each of those components because there's only one pathway. There's not what's called a junction where the current can kind of split off and decrease. Okay, in a series circuit, the current is the same through all components. However, the voltage is typically different across different components. Now, in a parallel circuit, it's the opposite. In a parallel circuit, you have different pathways that the current can take, and so that means the overall current can split until the overall current is not the same through each component. However, the voltage in a parallel circuit, the voltage is the same across everything. Okay, and so it's important that you understand those two facts about series and parallel circuits. Now, we've done basic problems using Ohm's law, which is V equals I times R. However, when you have a series or parallel circuit, it's not quite so easy. You can't just use that equation when you have a more complicated circuit. Okay, and the reason is because you have more than one resistance, and so you don't know which resistance to use V equals IR on. Okay, and so when you have a series or parallel circuit, what you can do is you can actually combine and simplify those circuits down using what's called the concept of total resistance. Okay, and so the idea of total resistance is we're going to take a complicated circuit and we're going to simplify it down to a simpler circuit. Okay, that's basically the idea of total resistance. Now there's equations to calculate total resistance, but the equations are different for series and parallel. And so you need to make sure that you're using the correct equation when you're doing these problems. And so obviously the first step is to know, like, is this series or parallel? And then once you recognize that, figure out which equation should I be using to do this calculation. Okay, so we're going to start by finding the total resistance of components that are in series. And if we want to find total resistance in series, the equation is very simple. Okay, RT is the total resistance. Okay, all you have to do is add up the resistances. It says here R1 plus R2 plus R3 plus dot dot dot. That just means you keep adding the resistances until you run out. Okay, so in series, the total resistance is literally what it sounds like. It's literally just adding up the resistances. Okay, and when that happens, the total resistance that you end up with is always bigger than any individual resistance. Okay, which should make sense because obviously if you add more numbers together, you get a bigger number. Okay, so doing problems with resistors in series is very easy because find the total resistance just requires you to add up the values. All right, so let's take a look at some examples and you'll see what I mean with these problems. Okay, so we have over here a circuit. You can see the circuit diagram. We have a battery. We know that the long end is the positive side, and so the current is going to come out of the long end and go clockwise, and then it's going to go back in to the short end over here. Okay, so the current is going to go this way. Now, the first thing I recognize when I see the circuit is that this is a series circuit. There's only one pathway for the current to take. There's no splitting of the current. There's no junctions. There's only one pathway, so it's a series circuit. And that means if I want to find the total resistance, then I need to use the equation that was on the last slide. So the total resistance in series is just R1 plus R2 plus R3 plus dot dot dot. Okay, so in this case, the total resistance, R total, I'm looking only at the resistances. That's going to be 10 ohms plus 15 ohms plus 30 ohms. Okay, I don't care about the 110 volts because volts is not resistance. I only care about the ohms because that's the unit for resistance. So 10 plus 15 is 25, 25 plus 30 is 55, and so the total resistance is 55 ohms. And so that is the answer to the first question. Okay, very simple. Okay, just adding numbers. Now, what does that mean? So basically what that means is that I can simplify my complicated circuit down to something that looks like this. Okay, in other words, I can take a more complicated circuit like this, and by using the concept of total resistance, I can basically simplify it down, and this circuit is going to behave exactly the same as this other one that's more complicated. Once I get the total resistance, then I can use V equals IR, which is Ohm's law, to do calculations. Okay, the reason I couldn't do that to begin with is because V equals IR, if you have different resistances, you don't know which one to use. Okay, so that's the purpose of using total resistance, because you simplify all the resistances so you end up with only one overall total resistance, and then that's the resistance you use in V equals IR. Okay, so now it says use Ohm's law to calculate the current coming out of the battery. So I know V is 110. I don't know I, but I know the R, the total resistance, is 55. Okay, so I divide both sides by 55, and I get I equals 2 amperes. Okay, and so that is the answer to the second part of example 1. Okay, so that means 2 amperes of current comes out of the battery. Now the last question says how much current is flowing through the resistor R1. Okay, so current does not get used up in a circuit. I said this before, but in a series circuit, the current is the same through everything. And so if 2 amperes comes out of the battery, that means 2 amperes goes through R1, 2 amperes goes through R2, 2 amperes goes through R3, and then 2 amperes goes back into the battery. It's the same current everywhere because there's no other path for the current to take. Okay, so the current flowing through R1 is the same as the current coming out of the battery, that's 2 amperes. Okay, so pause there if you need to look at example 1 some more. Okay, example 2. Okay, so example 2 says calculate the total resistance and total current through the circuit. Okay, so I want you to pause it here. I want you to try to do the calculation for example 2 on your own. Okay, calculate the total resistance, and then once you have that, you should be able to use Ohm's law to find the total current through the circuit. Okay, so try and do that now. Okay, so the first thing I recognize is, hey, this is a series circuit, so the total resistance is just going to be R1 plus R2 plus R3 plus, if I had more resistors, I would add those. Okay, so that's going to be 15 plus 10 plus 6, and that's going to be 31 ohms. Okay, now that's the answer for the first part of the question. The second part of the question asks us to calculate the total current through the circuit. Now that I have the total resistance, now I can use V equals IR. I know the V is 10 volts. I don't know I, but I know R is 31. So I can divide both sides by 31 to get I by itself. And so in my calculator, I'm going to do 10 divided by 31. And 10 divided by 31 is 0.32 amperes. Okay, so that is it for example 2. Hopefully that is the answer that you got. Pause there if you need to look at that some more. Okay, so doing problems with series circuits is way easier than doing problems with parallel circuits. So now let's take a look at the equation for parallel circuits. Okay, so when you have resistors in parallel, the equation for finding the total resistance becomes more complicated. Okay, so here's what this equation looks like. When you have parallel circuits, to find the total resistance, what you do is you do 1 divided by RT is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 and so on. And so it's actually way more complicated. Rather than just like adding the numbers, you have to do, all this other stuff. Okay, there's an interesting property of adding resistors in parallel. Because it's 1 over the resistances, the more you add, the smaller the total resistance ends up being, because you're basically adding fractions. Okay, so make sure you have this equation written down, and then we will do some simple calculations. Okay, aside from the equation to find total resistance, the way you do these problems is basically the same. Okay, you find the total resistance, and then once you have that, then you can use Ohm's law, V equals IR, to find the current coming out of the battery. Okay, so example 3, this one doesn't even involve like a battery or current or anything like that. This one just says calculate the total resistance through the segment of a circuit. Okay, so the first thing I do is I look at this, I say, well, there's multiple pathways, so it has to be parallel. Okay, so if I want the total resistance, I have to do 1 divided by the total resistance is equal to 1 over 12 plus 1 over 4 plus 1 over 6. Okay, now there's a few different ways to do this. You can do this in the calculator if you would like, or if you don't have a calculator, or if you want to do it by hand, you can also do it just by adding fractions. And the way you would do that is you would find the least common denominator, and then you would use that to add fractions. Now, if you don't want to do all that, again, you can just add these numbers in the calculator, and then do 1 divided by that number to get the answer. Okay, but I'm going to do this by fractions. So 1 over 12 plus, so 1 over 4, if I use 12 as my denominator, 1/4 is the same as 3 over 12. Okay, and then 1 over 6 is the same as 2 over 12. Okay, now that they have the same common denominator, I can just add the top numbers. 1 plus 3 plus 2 is 6. And so 1 over R total is equal to 6 over 12. But I don't want 1 over R total. I just want R total. Okay, and so to get the answer, I need to flip both sides. And so that becomes 12 over 6, which is 2 ohms. And so that is the total resistance of the circuit. And as you can see, parallel is way more complicated than series. Now, did I have to do it with fractions? No. Again, you could have done that in the calculator. You just would have done like 1 divided by 12, enter, plus 1 divided by 4, enter, plus 1 divided by 6, enter, and then you would have hit the button on your calculator that says x to the minus 1, which is the reciprocal button, which basically just flips your fraction, and you would have gotten the same answer, which is 2 ohms. Okay, so pause there if you need to look at that some more. Okay, so let's do a couple more examples with parallel circuits. Okay, example 4. Example 4, the first question says find the total resistance in the circuit to the right. The first thing I see when I look at this is I say, okay, that's a parallel circuit, so I need to use the big ol' equation for total resistance. 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, etc. Okay, because it's parallel. So 1 over R total is equal to 1 over 3 plus 1 over 5 plus 1 over 6. Okay, and you can do this in your calculator if you would like. I will do it using fractions just because it's a little easier to me. When I look at 3, 5, and 6, it looks to me like I can use 30 as a denominator. Okay, 1 over 3 is 10 over 30, plus 1 over 5 is 6 over 30. And again, if you hate fractions, that's perfectly fine. You don't have to do this with fractions. You can do all these calculations in your calculator. 1 over 6 is 5 over 30. Now that they have the same denominator, I can just add the top numbers. 10 plus 6 plus 5 is 21 over 30. And that's equal to 1 over R total. And so to get R total, I just need to flip that and get 30 over 21. Okay, and so if you did it in the calculator, if you did not do fractions like I did, then you should get 1.43 ohms as the total resistance. Okay, sometimes you're going to get decimal answers, and that's okay. Okay, so that is the total resistance of the circuit. Now, once you've simplified the circuit down and found the total resistance, then you can go back and use Ohm's law, right? V equals I times R, to find how much current is coming out of the battery. We know V is 9 volts. We're looking for I. R is 1.43 because that's the total resistance. And so to get I, I'm going to do 9 divided by 1.43, and I get 6.3 amperes. Okay, so that's the current coming out of the battery. Now, unlike in the last example we did with the series circuit, the current is not going to be the same everywhere in the circuit, because what's going to happen is the 6.3 amperes is going to come out of the battery, and it's going to hit this junction right here, and it's going to split. And some of the current's going to go that way, and some of the current's going to go that way. And so that 6.3 amps is going to split. All right, so I don't know the current everywhere. All I know is the current coming out of the battery. Now the last question though says how much voltage is there across the 3 ohm resistor. Now in a series circuit, the current is the same everywhere. In a parallel circuit, the voltage is the same everywhere. And so I can answer example 4 right away. The voltage is going to be 9 volts. Because it's parallel, and if you look in your notes, it says this multiple times, in a parallel circuit, the voltage across each component is the same. So 9 volts, 9 volts, 9 volts, 9 volts. Just like in a series circuit, the current is the same everywhere. In a parallel circuit, the voltage is the same everywhere. All right, so pause there if you need to look at that some more. Okay, and very last example. This is example 5. Calculate the total resistance of the circuit shown to the right, and then calculate the total current coming out of the 9-volt battery. Okay, so I want you to pause it here and try to answer example 5 on your own. Just to help you out, I will write down the equation for total resistance for a parallel circuit. That's 1 over R1 plus 1 over R2 plus 1 over R3, etc. Okay, so you should be able to use that equation to find the total resistance, and then use that to find the total current coming out of the battery. Okay, so pause it there and try to do example 5 on your own. Okay, so to find the total resistance, 1 over R total should be equal to 1 over 90 plus 1 over 45 plus 1 over 180. I could do that in the calculator if I wanted to, but just to save time, I'm going to use the least common denominator, which looks to be 180. So that's going to be 2 over 180 plus 4 over 180 plus 1 over 180. Okay, that's going to be 7 divided by 180. And so to get our total by itself, I'm going to flip that fraction, and I'm going to end up with a decimal. Okay, 180 divided by 7 is going to be 25.7 ohms. Okay, so the total resistance is going to be 25.7 ohms. Now the last question says calculate the total current coming out of the battery. Now that I have R total, I can use Ohm's law, V equals I times R, and I can use that to find I. I have 9, I is my unknown, and I have 25.7 is R. I divide both sides by 25.7, and I get the total current coming out of the battery, which is not going to be the same as it is everywhere because the current can split because it's parallel. It's going to be 0.35 amperes. Okay, so that is it for example 5. Hopefully that is the answer you got. All right, as always, please let me know if you have any questions. This, I believe, is going to be the last video that we do this year, unless I'm mistaken. And so I hope you guys all have a good rest of your school year and you have a good summer. And I wish you luck moving forward. Have a good day.